Hello, in this video I will explain divisibility rules. Then I will solve divisibility problems. So what do we mean by divisibility rules? Well, divisibility means can one number divide into another number evenly with no remainder? Okay, so let's take a look at a couple of examples here. So here we're asking the question, is 9 divisible by 3? So let's use long division to find out. 3 goes into 9 3 times. 3 times 3 is 9. We subtract. The remainder is 0. So the answer is yes. 9 is divisible by 3. And the reason is the remainder is 0. Okay, so that's what it means for divisibility. For a number to be divisible by another is that the remainder must be 0. Now let's look at another example down here. Let's see if 10 is divisible by 3. Well, 3 goes into 10 3 times. 3 times 3 is 9. We subtract, but we have a remainder of 1. See that? So 10 is not divisible by 3. And the reason is we have a remainder other than 0. So that's the key. The remainder must be 0. So keep that in mind for divisibility. Now, the other question is, why do we care about divisibility? And the answer is this is a shortcut to avoid long division in certain problems. Okay, so we use divisibility to avoid long division to determine if one number is divisible by another. And you will see more the application of this when we get deeper into fractions. We are going to look at 5 different numbers for their divisibility. We're going to look at the number 2, 3, 5, 9, and 10. Other numbers have divisibility rules, but we're only concerned with these numbers. So for the number 2, what does the rule say? Let's see what the rule says. A number is divisible by 2 if its ones digit is even. Okay, and even means that digit has to be 0, 2, 4, 6, or 8. So a number is divisible by 2 if its ones digit is even. So if we look over here, these are examples that actually work. They are divisible. So here we have 10. Is 10 divisible by 2? Yeah, because the ones place is even. How about 86? Same thing. 6 is even. We'll look at 102. The 2 is even. We'll look at 384. 4 is even. So it doesn't matter how big the number is, as long as the ones place value is an even number. Then it's divisible by 2. Now, we'll come back to 3 in a minute. Let's jump to 5. A number is divisible by 5 if its ones digit is 0 or 5. So here again, we have to look at the ones digit. The ones digit. If the ones digit is 0 or 5, then 5 divides into that number evenly with no remainder. And that kind of makes intuitive sense, right? Because take multiples of the number 5 and think that through. 5, 10, 15, 20, 25, 30. You notice how the right-hand digit, the ones digit, flip-flops between 0 and 5. So that's the rule for 5. Let's jump over 9 and come down to 10. A number is divisible by 10 if its ones digit is 0. So if the ones digit of that number is 0, 10 divides into that number evenly with no remainder. And I think that also makes intuitive sense, correct? Think, for example, 10, 20, 30, 40, 50, 60. 10 divides into those numbers evenly with no remainder. And notice how all those numbers have 0 at the end in the ones place value. Okay, so now let's jump back to the number 3. This is a little bit more complicated, but not super difficult. A number is divisible by 3 if the sum of its digits is divisible by 3. So what it's saying here is if we add the digits of a number, so let's take 18 for example. If we add the digits, what do we get? 1 plus 8 is 9. Then we ask ourselves, can 3 divide into 9? And the answer evenly, and the answer is yes, it does, because 3 times 3 is 9. So if the sum of the digits, which is 9 for this example, is divisible by 3, then automatically 3 divides into the original number evenly with no remainder. Okay, same thing here. 3 plus 6 is 9. Does 3 go into 9? Yes, it does, evenly. So therefore, 3 automatically divides into 36 an exact amount of times with zero remainder. In fact, 3 times 12 is 36, right? How about 123? That's a difficult one. That's a difficult one. So why don't we take a look at, let's do an example here on the board. So we have 123. Is this divisible by 3? Well, the rule says to add the digits, right? Add the digits. 1 plus 2 is 3. 3 plus 3 is 6. So then we ask the question, can 3, the number we're looking at, divide into the sum of the digits evenly with no remainder? And the answer is yes, it does, because 3 goes into 6 2 times, evenly with no remainder. So therefore, guess what that means? 3 automatically divides into 123. You see that? You can make division easier and avoid long division. So you don't have to use long division to determine if 123 is divisible by 3. You can use divisibility rules. We added the digits, we got 6, and then we asked the question, can 3 go into 6 evenly? And it does, which means 3 divides into 123 evenly also. Okay, now let's take a look at the next one here, 609. Let's try 609. Okay, is 609 divisible by 3? We'll add the digits. 6 plus 0 is still 6. 6 plus 9 is 15. Does 3 divide evenly into 15? And the answer is it does, because 3 times 5 is 15. So if 3 divides into the sum of the digits, then 3 automatically divides evenly into 609. Okay, now let's go to 9, the number 9 down here. Let's see what that rule says. A number is divisible by 9 if the sum of its digits is divisible by 9. That sounds familiar. In fact, it's the same rule as 3. Why would you think that 3 and 9 have the same rule? I'll give you a second or two. And the answer is because 9 is divisible by 3. You see that? So they have the same rule, actually. So you don't have to learn a new rule. So let's do an example here. So we have, let's take a difficult one, like 162. Let's see. Is 162 divisible by 9? 162. We add the digits. 1 plus 6 is 7. 7 plus 2 is 9. Does 9, the number we were looking at, divide into the sum of the digits? Of course it does. It goes in there one time with zero remainder. Well, guess what? If 9 divides into the sum of the digits, 9 automatically divides into 162. And then we have 819. Okay, let's try that. That's a pretty difficult one. 819. Well, let's add the digits. 1, we have 8 plus 1 plus 9. 8 plus 1 is 9. 9 plus 9 is 18. So this is the sum of the digits. The number we're looking at is 9 for divisibility. So is 18 divisible by 9? And the answer is it is, because 2 times 9 is 18. If 9 divides into the sum of the digits evenly with no remainder, then guaranteed 9 divides into 819. So this is very useful in fractions, as you will see. Let's try some problems now in my math test. Okay, so question 3 says, which of the following numbers are divisible by 2? So they're giving us a list of numbers, and we have to write down here or type in whichever numbers are divisible by 2. Now recall that for the number 2, the number that we're looking at has to be even. So in other words, the ones place value has to end in 0, 2, 4, 6, 8. So any numbers that end in that, we're going to type in. And as always, be careful of the extra instructions. They want commas between the numbers. So let's just begin from left to right. We're asking the question, is 94 even? And it is. So let's put it in there, comma. 376, even. 1410, even. Again, I'm looking at the rightmost digit right here. It's a 0, so it's even, comma. 188, even. 470, even. Whoops, forgot the comma. 470, comma. 846, even. 846, comma. 11844. It doesn't matter how big the number is. If the last digit, the right-hand digit, is even 02468, then the whole number is even. So therefore 2 divides into this thing. So 11844. Now, the next one is 141. Well, that's an odd number. Odd numbers are numbers where the ones place value is 1, 3, 5, 7, 9. And 2 will not divide evenly into those numbers. So we're not going to put that in here. So that's odd. We're skipping that. 47 is odd. 705 is odd. 423 is odd. And make sure here when you put the last digit, don't have a comma again. The comma is only for between the numbers. All right, well, let's check and see if this is correct. And it is. Let's go to the next question. Now they want to know which of these numbers are divisible by 3. And recall for the number 3, we add the digits. Okay, we're going to add the digits. So follow along. We'll add these together mentally. You could write it down if you want, but let's try it mentally and see what happens. So we have to add the digits, right? 1 plus 8 is 9. 9 plus 5 is 14. 3 does not divide into 14 evenly. So we're going to skip that. 3 plus 3 is 6. 6 plus 3 is 9. Does 3, the number we're looking at, divide into the sum of the digits, 9? It does, evenly with no remainder. Therefore, 3 divides into 333 evenly. So let's put that in there. Let's go to the next one. 1 plus 1 is 2. 2 plus 1 is 3. Does 3 go into 3? Sure. So let's put 1, 1, 1 there. 5 and 5 is 10. 10 and 5 is 15. Does 3 go into 15 evenly? Sure. So that number goes there. Because if 3 divides into 15 evenly, 3 automatically divides into 555. See that? We can avoid long division. That's the benefit of divisibility rules. Let's go to this one. 2 plus 2 is 4. 4 plus 2 is 6. Does 3 divide into 6? Yep, sure does. So 2, 2, 2 goes there. Let's look at this one. 74. Well, 7 plus 4 is 11. 3 does not divide into 11. Skip. 8 plus 8 is 16. 16 plus 8 is 24. Does 3 divide into 24? It does, which means 3 divides into this thing evenly with no remainder. So 8, 8, 8 goes there. Let's look at this bigger number. 2 plus 6 is 8. 8 plus 6 is 14. 14 plus 4 is 18. Does 3 divide into 18? Yeah, 3 times 6 is 18. So if 3 divides into the sum of the digits that we're adding here, which is 18 for this example, 3 goes into 2664 evenly. So we put that down, 2664. Let's go to the next one. 1 plus 4 is 5. 5 plus 8 is 13. 13 plus 0 is still 13. Does 3 go into 13? Nope. Go to the next one. 7 plus 4 is 11. 11 plus 0 is still 11, but 3 does not go into 11 evenly. Next one. 1 plus 4 is 5. 5 plus 8 is 13. 3 does not divide into 13 evenly. Skip. Last one. 2 plus 9 is 11. 11 plus 6 is 17, but 3 does not divide in 17. So let's delete that last comma there so we don't get the problem wrong. So if we did everything correctly, this should be it. Let's see what happens. Let's check. And there it is. So 3 is a little bit more difficult, no doubt about it, because you have to add things. And like I said, you could do this mentally if the numbers are small, or if you need to, you can write it on paper. That's fine. Let's go to the next number, which is the number 5. Now recall for the number 5, a number is divisible by 5 if its ones place value, the ones digit, is 0 or 5. So this is going to be an easier one. 3 and 9 are the harder ones because we got add digits. The other 3 numbers, 2, 5, and 10, they're pretty easy. So here we go. 35, it ends in 5. Let's put it down. 63 does not end in 0 or 5. Nope. 21, nope. 105, yes, because it ends in 5. So 105 goes here. 42, no, it doesn't end in 0, 5. No, no, no. Yes, it ends in 0. So 5 divides into it. So 280. 140. Yes, it ends in 0. So 5 goes into it. So 140. 28, no. 56, no. So it looks like it's just these 4. Let's take a quick look again. 35, 105, 280, 140. Let's try it and see if this works. Okay, so now we're looking at the number 10, another easy one. A number is divisible by 10 if its ones place value is 0. So we're just looking for the right-hand digit to be 0. That's all. Nope, 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 nope. Yes. 1240. 1240 goes here because the right-hand digit, the ones place value, is 0. So 10 divides into this exactly a certain amount of times. By the way, divisibility tells us either yes or no. Does one number divide into the other number evenly with no remainder? It does not tell us, though, how many times. And when we use divisibility, we don't care how many times. We just want to know yes or no. We might have problems where we do need to know how many times, but that's a separate step. Divisibility just asks the question, yes or no, does one number divide into the other number evenly? We don't know how many times, but it's a yes or no question. All right. So we got 1240. Let's go to the next one. 620. Yep, it ends in 0. So let's put that down. 620. So this one, nope, nope. Let's get rid of that comma at the end. Let's take one last look. It looks like we have the right answers. Let's see. There it is. Okay, our last one has to be 9, and here it is. So yes, this is going to be a difficult one because we have to add digits. And as I said, you can put it on paper if necessary. So the sum of the digits, we're going to add these digits. If 9 divides into it, then 9 divides into that other number evenly also. Here we go. And let's go up and down it so we don't get mixed up. 46, 4 plus 6 is 10. Does 9 go into 10 evenly? Nope. 2 plus 3 is 5. 5 plus 0 is still 5. Nope. 6 plus 9 is 15. Nope. 9 does not go into 15 evenly. 1 plus 8 is 9. 9 plus 4 is 13. Nope. Does not go into 13 evenly. 4 plus 1 is 5. 5 plus 4 is 9. Does 9 divide into the sum of the digits, which is 9? It does. So therefore, 9 divides into 414 evenly. 2 plus 3 is 5. Nope. 6 plus 9 is 15. 15 plus 0 is still 15. 9 does not divide into 15 evenly. Nope. 6 plus 9 is 15. Nope. 3 plus 4 is 7. 7 plus 5 is 12. 9 does not divide into 12 evenly. Nope. 9 plus 2 is 11. Nope. 5 plus 7 is 12. 12 plus 9 is 21. 21 plus 6 is 27. Does 9 divide in 27? Yes, it does, because 3 times 9 is 27. Therefore, 9 will divide into this number here with 0 remainder also. So let's put that down. 57, 96, comma. How about this last one? 2 plus 0 is still 2. 2 plus 7 is 9, and 9 goes into 9. So 207 belongs here. Okay, so looks like we have our numbers. Let's try it and see if we did everything correctly. Okay, so there it is. You will find divisibility rules very helpful when you get to the fractions part. So in the meantime, what you want to do is practice, right? You want to memorize these. So thank you for watching the video. Now it's your turn.